Have you ever noticed how the top few floors of a tall building always sway with the wind? Or how when a mass is put on a spring and is pulled, the spring oscillates up and down? Both of these motions take place for a period of time before coming to a stop. Damping is a phenomena whereby the amplitude, the point of maximum displacement, of vibration of any oscillating motion gets progressively smaller with time. Take this pendulum bob. When I displace it from its equilibrium position, I provide it with gravitational potential energy, as I have increased its height from the point at which it started. If I release the pendulum from this position without giving it a driving force, it will never reach the same height that it started at. Let me show you. Eventually, the pendulum stops oscillating and returns to its equilibrium position. In the example of the pendulum bob, the reason for which damping occurs is because at each stage of motion, there is air resistance acting on the bob in the opposite direction that it's moving in. On top of that, the string that the bob is hanging on is not perfectly smooth. It can never reach the same height that it started from, as not all the potential energy is conserved due to energy being used to overcome these resistive forces. This graph illustrates how the amplitude of the motion of the pendulum changes with time. It can be seen that the amplitude decreases as time goes on. The amplitude decreases in such a way that it tends towards zero. Most systems in industry are artificially damped to reduce unwanted vibration. An example of this is shock absorbers on tennis rackets.